Hello and welcome to today's webinar. This is part of Net Zero Live. I'm Chloe McCulloch, Buildings Editorial Director, and this webinar looks at tackling carbon emissions across the built environment supply chain. With me today, we have Tim Clement, Director of Sustainability at Morgan Sindall Construction. We have Ashwin Halaria, Associate Director at Symmetries, and we have Annalisa McSweeney, Sustainability Lead at White Architecture. So today the panel will explore how to identify, measure and mitigate carbon emissions across the supply chain from raw materials through to construction and operation. They all have their own areas of expertise, so their presentations will focus on different aspects of that. But I think it's fair to say that we will cover questions around how to assess and analyse the footprint of your supply chain, how to explore strategies for sourcing materials and products, innovative uses of construction techniques and technologies, and also understanding the importance of collaboration and transparency amongst all the stakeholders in a project to reduce carbon. A quick reminder that you're very welcome to post questions throughout the hour, and we will have a Q&A session at the end. So if you are posting questions and we haven't got to them, I haven't forgotten you. It's just we'll keep that bit to the end after all the presentations are done. So do keep posting your questions and I will look out for them. Also, we have a lot of people on this call, so I might not get to every question, but I might sum up several questions in a sort of topic area. And also, just to remind you that this webinar is available on demand. So when this hour has finished, we will do our best to quickly get the webinar up so that you can share it with colleagues if they haven't had time to join us right now. So I think that is probably enough for me. I'm going to invite Tim to share his screen first. The rest of us are going to turn our webcams off and we will join you after Tim's presentation. Over to you, Tim.
Thank you very much.
That's looking great. That's all displaying fine, Tim. Thank you.
Excellent. Well, it's nice to see everybody today. Thanks for joining. So I'm going to spend 10 minutes talking about our view at Morgan Sindall on this huge topic, tackling carbon emissions in the supply chain. And the way we like to go about that is just to contextualize as a construction business what our approach is to carbon emissions and governance and what that means in practice. So along the top are sort of the governance aspects of us as a company, some of them relating to Morgan Sindall Group. We're an early adopter of science-based targets, and I'm not going to go through each one in turn. But what I want to say about supply chain is that with strong governance and transparency, there are tangible outputs to that. It's not just about box ticking. As a result of some of those things across the top, we created a carbon calculator called Carbonica. So it measures the carbon impact of the projects that we deliver, and I'll explain that a bit more in a minute and how that's relevant. We have an initiative called the 10-Ton Challenge and an R&D project called the Circular Twin. And it's those three things that I briefly want to touch on this afternoon. And all three, in some way, came out of the governance. So the governance came first, and those three things came out of it. And the reason I feel it's relevant for today, when we're trying to look at such a big, wide-ranging topic, is this on the screen. This is our supply chain carbon maturity framework that we put together a couple of years ago. And essentially, it's a way of us as a tier one contractor supporting the further supply chain to adopt a similar approach, because we've seen the benefits of that. So our maturity framework is about the governance, sort of having the knowledge first, of course, but then measuring carbon emissions. The third level is disclosing those carbon emissions publicly, and the fourth one is setting targets. If I'm completely honest, I think we have some work to do on this, particularly in how we support SMEs. Just to preempt that question, there's certainly work to do on that. But the principle, which I want to underline, is measuring carbon emissions, publicly disclosing them and being transparent, and then setting targets that are based on science to reduce them is for us the foundation of our activity, and that's how we support our supply chain. So I want to mention now these three things: Carbonica 10 Ton Challenge, Circular Twin, just to give a flavour for how we approach it, maybe to prompt questions, maybe even, if I'm lucky, to inspire someone on this call today. So Carbonica, it's a whole life carbon assessment tool we developed over the last 6 years. Its mission is to reduce carbon, firstly, but also to be highly credible, robust, and easy to use, because it's a tool for our project teams to use. It's a tool for a non-expert, and by expert I mean carbon expert, a non-expert, to complete it. And because of that, we use it on about 50% of our projects at the moment. And the outcomes there at the bottom, the one I want to mention, yes, carbon reduction is super important as a key aspect of the tool, but project specific. When we work with the supply chain, we can tailor an assessment to be specific to a project. And the way this helps us to reduce carbon, if you're interested to find out more about the tool, by the way, there's a QR code there. Cue 5 seconds before I move on from the slide. Quick camera movements, clicking the button. Quick, right, on we go. Is to have a good carbon assessment, we need good data going in. And you may have heard of, or may be familiar with embodied environmental product declarations, EPDs. So behind Carbonica is a set of generic carbon data, sort of some product declarations about some products for specific things. But really, what we get out of that is still a generic carbon assessment for a building. And there are some real differences between products. And if we're thinking about selecting a product based on carbon, that's quite a dangerous thing to do unless we really know about it. And the other thing I'd say there is I recently went down a British gypsum mine in Leicestershire, and they've recently converted their trucks, their underground trucks, to be electric. So clearly, if they have an EPD for a product now that's got a validity of 5 years, it won't reflect what they've done in the last year, for example. And that's just to illustrate the point of, unless we really know about a product, can we honestly make those decisions correctly about we're going to use this product instead of this product? But just leave that thought hanging. Environmental product declarations, nevertheless, are much more specific than generic data. So we always ask our teams, add the EPDs. If they're already in the database, that's great. If not, what about all these other questions? So when we built the tool to interface well with the supply chain, so we can ask these questions, and the answer to these questions changes the carbon number and therefore might affect the decisions made on a project. So replacement cycles, how long will it last? Transport distances, type, how likely it is a product can be dismantled in 60 years and used again. And I'm not going to carry on. But those questions influence the carbon number and ultimately decision making. So this project, the Circular Twin, we assembled this design team at the bottom and tried to understand, if we put carbon in front of capital expenditure, what would be the result? I'm not going to go in detail just because of time. I'll finish about 12, 13 minutes past 2. But what we found is if the supply chain are involved at REBA stage 2, concept design, it's likely there'll be a different outcome, a different design, and also different behaviors in the process. And that's one of the key findings of this project. I won't explain the project in its entirety. And again, there's a QR code there if you're interested to find out more about that project. But the supply chain being involved early led to a different outcome in terms of what the building looked like, how much it cost, and what the carbon intensity was. All for the better. Well, I suppose the first one's subjective, but all for the better. So how we approach this, oh, by the way, top right, that's the electric truck at the British Gypsum place. So how we approach it is these documents we put together in collaboration with the supply chain and the data to give our teams the knowledge they need to sort of talk to our project teams, customers, design teams about what should we do to reduce carbon. And we filter them, and we don't apologise for editing them. Some things we consider greenwash, and I'm not going to pick specific things out just now, not to be controversial. But if there's something that feels like greenwash, it's not quite, it's a carbon neutral product, that's always sort of raises a red flag to us. We won't include that, or we'll ignore the comment. And this allows us to edit and curate guidance for our teams that's in line with who we are as a transparent organisation that wants to be a leader in low carbon construction. So finally, before I finish, just want to tell you about our 10-ton challenge and why that's relevant to the supply chain. In sort of behavioural thinking and research, there's this idea that individuals need the motivation to do something, they need the ability to do something, but they also need a prompt, and in order for something to change. And our prompt is called the 10-ton carbon challenge. It's where we prompt our projects 3 or 4 times a year to find creative ways of reducing carbon with our supply chain. So that's about getting our supply chain to come up with ideas, innovations to reduce carbon, either challenging the specification and design of a building while it's still in REBA stage 3 or 4, or in the procurement of products, or even in how we just run the site, like reducing waste or using different fuels. And that's how much we've saved in 2 years. Same as heating the homes of all of our employees in Morgan Sindall Construction for 6 years. I'll just leave that on the screen as an example of one project where we've done that, and the steps they took as part of the 10-ton challenge to reduce carbon against a baseline. And Carbonica enables us to do that because we have a way of measuring it. We baseline it, REBA stage 3 or 4, or even 2, if we're involved early enough. And then as we go through, we can see the changes. So that's me. That's just a sort of brief overview of how we approach this, and maybe prompting some questions or some thoughts about tackling carbon in supply chain. So thank you.
Thank you so much, Tim. I'm just going to, just before we go to our next speaker, I just, for our audience, I just wanted to ask you a little bit more about the Circular Twin project. I know you had the QR code so people could follow that to find out more, but that was a Circular Twin project. Was that an actual live built out project, or was that a sort of experiment in theory?
It was a theoretical experiment based on a project we delivered. So we took a primary school we delivered in 2017, and all the drawings and the energy data from that building in use, and we used that as the baseline. So we ran a theoretical REBA stage 2.
Right, I've got it. And so do you feel that there is an approach here where you need to have some space to experiment, take a risk outside of a live project, so to speak? And do you feel that those opportunities if you do feel that's important, happen regularly enough in the industry for tier ones?
No, they don't happen regularly enough. I think that's without that time and space to do that, we wouldn't have any of that knowledge. We were commissioned by the UK Atomic Energy Authority to conduct a similar exercise, and then we conducted a third as well, and now we're on a fourth that's ongoing, which is more about regenerative construction. And well, unless we've got that time, we don't know what we don't know, and we risk just repeating the same behaviours if we try and shoehorn them into live projects.
Thank you very much. We may well come back to that in our Q&A. I feel like there's a lot to sort of unpick there around sort of experimentation and collaboration. But thank you very much for now, Tim. I'm now going to invite Ashwin from Symmetries. Hi, Ashwin. If you can share your screen.
Yep, I'll just share that. Hopefully. So hopefully you can see that okay?
Yeah, that's appearing fine. Thank you.
Okay, brilliant. So I am Ashwin Halaria. I'm Associate Director at Symmetries. We're structural and civil engineers. And I'm going to talk about our journey to reusing steelwork, simply because it's a journey that could be used on various different materials in the construction industry. So I'm going to start talking about why reuse steel. I'm going to talk about the reuse cycle that we currently implemented, and then the ideal cycle, and the tool that we developed called Ferris wheel, and how you can help. So just a reminder, the reason why we're all here is because of the climate crisis. The construction industry is responsible for a large portion of the CO2 produced. So high level, what happens to steelwork at the moment once a building has reached its end of its life? So 87% goes back into recycled, 10% goes as reuse, and 3% goes into landfill. Now, 87% recycled would be something that we were probably very proud of, but let's look at the carbon emission. So we're going to use some data from Cleveland Steel, and they based it on a 12-meter tubular section. So a virgin steel would have 7,725 kilograms of CO2 equivalent. A recycled steel would have 1,232 kilograms of CO2 equivalent, and reused is only 284. So there is a big difference there. And so that's the main reason we're promoting reuse. So just going into recycling, the process. So when a building's demolished, a steel building's demolished, the steel is typically cut up into small segments. And this is partially because it makes it easier and quicker to demolish. It's then transported to the recycling center, and then it's then melted in the arc furnace. And this is where the large portion of the carbon emissions is expedited. And then there's a recasting and refabrication process. So how do we go about reusing steel? So I'm going to talk you through how we kind of got there. So just a high figure to level figure that I want you to remember. There's a 96% carbon saving when compared to virgin steel. So the benefits are completely clear. So what cycle we've achieved so far is we've got a live building that needs a lot of steelwork. We've identified a building that is being demolished. We've looked at the steelwork, done a desk-based study. We've then approached the demolition contractor and look at how they could deconstruct it to harvest the steel. We've then had to send that steelwork to a supplier who's tested it and cleaned it up, ready for fabrication. So we've been involved throughout that process. Before I go into the ideal cycle, I want to give you some headline kind of cost figures. So virgin steel currently costs around about £780 per ton. Reclaimed steel is about £800 per ton, so not much different. Scrap steel is about 230 tons, £230 per ton. So you can see that there's a big difference between scrap steel cost and the cost of reclaimed steel. And that's a key point that we want people to take away, because demolition contractors could typically earn £450 per ton for every ton they harvest instead of scrapping. New eco steel is £940 per ton, but it doesn't have the as large of a carbon saving as the reclaimed steel. So we developed a tool called Ferris Wheel. It's with the help from collaboration with London South Bank University. And the idea was to try and keep the harvesting steel side section with the suppliers and the design side with the engineers and the construction team. So you can seamlessly, you've got a need for a piece of steel, you go to Ferris Wheel and you run it on your Revit software, and it brings back, it looks at the supply chain, matches what's in stock with what's needed, and then we will go into the filtering process on what steel is appropriate. We'll look at what damages and dents, indentation it has. We'll look at what holes and services, cutouts it has. And then we've identified the steel. We're going to ask the contractor to secure that supply ready to provide to the fabricator. And the great thing about this this new supply chain and having this Ferris Wheel tool is it makes it seamless to be able to go out to the market and find out where that chain is available, where that supply is available, and it makes it easier for stockists to advertise what they've got available. So, and it all works in the Revit model, and so anyone, a QS, structural engineer, a developer, can use this tool to quickly source what's available. To give you an example of where we've successfully used this, 55 Great Suffolk Street is a Grade 2 Victorian building, and we are currently working, we've completed the design of its refurbishment. So it's got this stair court at the back. Typically, it would be virgin steel would be the default choice. We've retrospectively run Ferris Wheel, and we've managed to source 97% of the steelwork from reclaimed supply, and that's an incredible amount. And to give you an idea, again, a take-home figure, reclaimed steel, you've got two tons. Reused steel is 2 tons per kilograms of equivalent of CO2, and versus the virgin steel, which is around about 38 tons. So that's a 36-ton saving, the effort required was coordination with the architects was key, making sure the depths, we have plenty of floor to ceiling heights, and that's because our supply chain is limited. If we could improve confidence, we can get a bigger supply chain going. So what are the challenges to bringing confidence and bringing this to the wider market? So at the moment, demolition contractors want to chop up their steel because that's what they know. So we need to, it's an education process almost, we need to explain to them that there is a monetary benefit. They could earn a great amount. And yes, will it be difficult for them? Yes, it's going to be difficult because they're used to chopping it up, and deconstruction would be something new that they do. So the second point is that not all stockists and fabricators accommodate reclaimed steel. There is 2 main suppliers that have entered the market. We need more suppliers to enter the market, and that will come with confidence. Finding suitable sections, Ferris Wheel is there, but we need to work on Ferris Wheel and improve it. It was released about 4 weeks ago, and it's something that we want to continuously develop. And high-tech challenges. So one of the things we are aware of is the bigger fabricators have struggled to use some of these reuse steelwork because their automated machinery has automatically rejected it. Dents and holes have been kind of identified by the machinery, and it's been pushed out. There's still a large learning process. So what are the next steps? How we're going to bring confidence and how we're going to bring this as a norm? So we need to get more stockists involved. We need to get more fabricators and more demolition contractors working in the supply chain. Research, there is some research being done by numerous structural engineers, universities. We need to build on that, but we also need to continue developing Ferris wheel. Legislation is key. We need to make sure that there's tax breaks for steel reuse, and that demolition contractors, incentivize to deconstruct a building instead of chopping it up into pieces, so that we can benefit that carbon saving. And this will naturally bring confidence in the market. Confidence in the market is a really key point, I think, actually, because the moment you have confidence, you've got more people, more stockists enter the market, you've got more demolition contractors selling to these stockists, and then you've got more developers, fabricators being able to source from the market. So it's one of the key points. And then the final point is designing for deconstruction, making sure buildings can be deconstructed so that that reusing is the natural process. I think that's where we are. So just to give an answer, we need confidence, and that's the biggest message I will send out there.
I was just going to ask a couple of questions off the back of that. It's a really interesting presentation. Also, it sounds like this is, this Ferris wheel product is very new. So you said it's just been launched 4 weeks ago. Is that right?
Yeah. So we launched it 4 weeks ago as a kind of a testing edition. We need to continue developing it. We're looking for funding so that we can do the next phase of its development. It's really great it links really well with the Cleveland steel supply chain, but we need it to then develop it so it can be adapted for the ever-growing supply chain.
So the idea is you started it with certain industry partners, and was it South Bank University?
London South Bank University, yeah.
And then is the vision for it to become a licensable bit of software, or
it's free to use, and that's the key, because we want to be part of the cog that drives the supply chain, and Ferris wheel has the power, and there's other rival softwares being developed, and I hope that everyone contributes, because it's through teamwork that we're managing to achieve this. And if you like, it's a testament to the industry. The construction industry has always been slow to adopt new technology, but in this case, it's been really, really remarkable how quickly it's been adopted, because we did the initial research, and as a SME, there's a certain investment we can make in that, but then we've had other engineers, other universities jump in that and fill in the bits of the missing parts of the research. So working as an industry to make sure we're driving this, the research, making sure we're driving the technology and driving the experience.
That sounds great. If people are on the call and they want to find out more about Ferris wheel, or get involved, or find out about its next stage, where do you suggest they go?
Please go to our website. We've got the link where you can download it and test it and give us any feedback you have. And we're hoping that we can start with we can start applying for more funding so that we can continue to refine the product.
That sounds great. Okay, well, thank you so much, Ashwin. I'm sure there'll be more questions about steel reuse in our Q&A session. I would encourage the audience just to post any questions that you've got, and we will get to them after our last presentation, which is going to be by Annalisa. So Annalisa, I will invite you to share your screen.
Hi, thank you. Sorry, I was just furiously writing notes after Ashwin's presentation. I will share the screen, and hopefully you can see that okay?
Yeah, that's full screen. Thank you.
Lovely. Okay, so I wanted to start by highlighting that whilst this conversation is about decarbonising the supply chain, we really must look beyond the carbon tunnel vision. And this when considering material decisions, so that we can shift to a more regenerative mindset. And that considers other far-reaching externalities and co-benefits. So at White, we have introduced the term regenerative into our business plan. And this is recognizing that sustainability isn't enough. We can't sustain what we're doing now, and we need to restore nature and create resilience. And more on this upcoming in a new Architects Declare Regenerative Practice Guide that will be coming out. And I can send links to that when it's available. So as an organization, we're entirely employee owned, so we can make independent decisions on the metrics that we decide. It also enables us to invest large parts of our profits into the research and development that is fundamental to the practice in its projects. And White has a breadth of experience and research surrounding the use of timber and other natural materials, and a long-standing track record across a wide range of sectors and disciplines. So drawing from our experience in healthcare, we won the competition for the new Velindre Cancer Centre outside of Cardiff in 2022. And the new building measures around 36,000 square metres, is comprising a mixture of the state-of-the-art clinical research and educational facilities, and currently it's in stage 4. And we were drawn to the client brief, which is prioritising the importance of nature. From the beginning, we were working to the same vision and goals with our client and construction team. The brief included many documents and requirements, including the NHS Net Zero Building Standard that came out earlier this year. But I'd like to draw attention to one, and that's the Future Generations Act. And this is a piece of Welsh or Wales-specific legislation that places future generations and the health and well-being at the heart of any new civic infrastructure. And as we know, there are many challenges to a growing healthcare sector, including a changing demography and aging population. And we believe a holistic approach is needed to meet the project's aims and to respond to the climate emergency. And to this, well, critical to this is the material palette. So we went through a really rigorous process, analysing the material choices, focusing on the nature-based and low-carbon solutions at the bottom of the pyramid, rather than the heavily manufactured or petrochemical ones that are based at the top of the pyramid, and which are also very high carbon solutions. But just using natural products isn't enough. Effective and efficient use of resources must be combined with good material care. Mass timber construction, for example, takes huge quantities of trees, given the inefficiencies when we start to oversize for charring and obtaining straight structural lengths. And so we really must ensure that timber is kept in use for longer than it takes for the tree to regrow. And that's much longer than current business as usual lifespans of buildings. And this is an issue that we explored through the installation we were invited to give at this year's Venice Biennale. It was titled 150,000 Trees, and it interrogated the material use on the Sara Kulturhus project that we have in Skellefteå. Now, Velindre has a hybrid structural strategy that is designed for maximum material efficiency. We have concrete to the high-tech and vibration-sensitive areas, and we have timber structure to the low-tech and public areas where it can also be exposed. The external palette draws on inspiration from local manufacturing traditions and heritage. We have recycled limestone gabion walls, we have timber, reclaimed brick and recycled copper, and all of this is with a hemp and lime backing wall. And we came to this material decision by analysing, comparing the embodied carbon, the durability, the cost, the reuse and recyclability, the toxicity, and the cultural value. And we put a score against each one, and this helped to support an informed design decision that in the end favoured natural materials. In order to minimise ecological damage in construction, we really must transition to using a variety of responsibly sourced bio-based materials that are suitable to the project context. And these non-toxic materials contribute to the well-being of people and are shown to give economic benefits. For example, reduced sick leave and improved efficiency of staff. Our intent is for a hospital that looks and feels non-institutional, exploring bio-based materials for their calming properties, their better acoustics, and improvement of air quality. So what are they? Well, bio-based materials or natural materials, they're abundant and replenishable materials that require little energy from their natural sourcing, processing, and manufacturing, and as such can decompose back into the earth at the end of their service life, or be easily recycled and reused. And our interior finishes palette includes timber, natural linoleum, and mineral plasters, including clay and lime, as a lining to the hemp block external envelope. So as part of a national decarbonising strategy, it's necessary that we draw down carbon to create large carbon sinks and store some of this in large scale within our built environment. Hemp is a very fast-growing plant, and it's said to be more effective than forest or commercial crops at absorbing CO2 per hectare of land. In addition, it does not compromise land use for agriculture, as hemp can be grown as part of a crop rotation and even has potential to improve subsequent crop yields and soil health. Now, the aspiration to minimize embodied carbon in construction leans towards the use of more natural materials. However, there are a few natural fiber insulation materials that will also achieve necessary fire performance. High-density hempcrete blocks, however, are non-flammable. And hempcrete is insulating as well as providing mass. It regulates fluctuations in internal temperature and improves comfort, so reducing the need for mechanical heating and ventilation and the operational energy. And the diagram shows how building with hemp can simplify the external wall buildup. However, there are challenges in scaling up a product that's typically used for a domestic scale. For the hospital, we had to ensure early engagement with the supply chain to ensure the actual supply of the hemp, enough time in the process for necessary testing to make sure that the blocks are used as infill walls between the hybrid structure we described. And the biggest challenges have been supporting and fixing a rain screen cladding over those spans, the need for an additional insulation to wrap the slab edge so that we can achieve the kind of onerous U values, and the detailing of the air tightness layer that we're doing through breathable lime clay renders. So we're using mineral plasters and internal lining, and they are fully breathable and hygroscopic. And this means that they absorb and release moisture and balance relative humidity, keeping it between 40 to 70%. And this reduces airborne bacteria and creates the ideal humidity for equipment. Lime plaster as an internal finish is alkaline and cannot harbor bacteria. But there are challenges of using natural materials in many sectors, especially in a hospital environment. And these include infection prevention, how do we deal with the cleaning routines and the chemicals used, the need for robustness and durability, slip resistant, color and contrast, all whilst avoiding carcinogenic materials and formaldehydes. So I'm just quickly going to show the HBNs, which are the NHS guidance that outlines policy and performance requirements for the selection of finishes in flooring, walls and ceilings, etc. And simplified, the decision-making process looks a bit like this. You get the brief, a category of room space, the health and safety requirements, risk assessment, and then a decision. But we feel that these don't really address issues about embodied carbons, toxicity, chemical and water, material sourcing, and any other beneficial properties. So we proposed a more rigorous set of considerations and identified the key stakeholders inputted that was needed at different stages within that kind of specification process. And as of the building envelope, our decision-making was evidence-based. We looked at EPDs, for example, the resilient floors. We spent so much time comparing across the whole life cycle to find the best products on the market. We looked at the maintenance and replacement, the relative service life and durability, whether materials could be sourced locally, what their identity was, and at end of life, what percentage could be recycled, reused, or retained. And just to finish, I thought I'd just reflect on some thinkings from material reforms, from material cultures, about actually what is a regenerative supply chain. So we need to consider what are the resources. We're specifying resources that have to be produced, not just kind of these abstract components that appear. Are they grown or extracted? And how does that feed into ideas about regenerative farming? Looking at labor and land management, the value, the true cost of the material and what's costed outside of what the market measures. Effective material use and care in the long term to keep them in use for as long as possible, the ability to compost and return to the ground, how that impacts regional land use and distribution, and how can we take a more systems thinking approach. So thank you.
Thank you so much, Annalisa. I'm just going to bring you back just quickly just to talk about some of that really great presentation. But I suppose my question is, the emphasis that White now has on regenerative design, when did that sort of approach start for you, and what's the journey been to kind of get there? Because it does seem like a very you have to take a very rigorous approach, so you have to all be really on board and to be able to find the projects like this hospital just outside of Cardiff that will enable you to take that approach. So could you just explain a bit when you started down that journey?
Yeah, definitely. I think it's kind of a question of language, right? Like regenerative design is a term that's kind of coming in to play now. And as I mentioned through the work that I do with Architects Declare, we're really keen that this is safeguarded because it is more than just the ability to have the new sustainability word, and it is a different way of thinking. It's a systems approach to thinking. It's a way of thinking as humans co-evolving, thriving, supporting and having resilience as a part of nature as opposed to separate from it. I think that you see kind of glimpses of regenerative design practice historically. It's not a new idea. And especially within our work at White, we have kind of landscape teams that are really focused on how are we kind of giving back more to the land, how we're dealing with water mitigation, like kind of climate mitigation, and the adaptation element to do with like water and rainwater, and all these kind of very good practice things that are happening elsewhere. But the idea of regenerative all comes together when you're doing all of these things. And we've introduced that as a term into the business plan for the next 4 years, the latest business plan. And it is something that we are now very actively speaking about within our teams and across our different offices. But the introduction of that term, whilst I think the thinking has been there in a way previously, we're trying to kind of really take a very proactive approach to that, discussing it, addressing what does that mean, and how do we have to change in the way that we practice as ourselves as an organization in order to deliver regenerative products or projects.
Okay, thank you very much. Well, I'm going to invite our other two panelists to turn their cameras back on. And we have some questions that have come in. So I will start with them. I'll start at the top with the first one. Are you, so this is from Nicola, are you finding there's a discrepancy between what different clients are requesting in terms of cutting carbon? And from your experience, what is the top driver from a client perspective to drive the most effective carbon cutting? So I suppose that question is really asking around what are you hearing from clients and how uniform is it? Do you see a real range in sort of client behavior, and the ones that are asking for more in terms of carbon cutting, what are their drivers? I might start with Tim on that one.
Yeah, sure. That's a great question, and I think the short answer is there's a huge variety of ambitions, and particularly how those ambitions are manifested in a construction project. I think the ambitions are all quite similar, which is we have a net zero goal or a climate emergency declaration as a local authority or something like that. But quite a lot of those get lost in translation when it comes to the construction contract. And I think the simplest way is setting a target, but that's oversimplified. And I think where Annalisa finished on the presentation just now is probably a helpful way for clients to start to think about the interconnectedness of ambitions. Because at the heart of it, a lot of our clients are passionate about people, particularly our public sector clients, how the Social Value Act applies to them. And to be able to connect those things together in a framework or a way of procuring that allows different ambitions to sit side by side, such as health, improving communities, reducing carbon, will help. But that will need a little bit of time in the process to understand, well, what are going to be the metrics then to achieve those different things? It's not a direct answer, but that just some thoughts.
Thank you, Tim. I might move to Ashwin because your presentation was really around reuse of carbon and a sort of an attempt by the industry to come up with solutions. But do you see a driver coming from the clients as well?
Yes. So we find that our larger clients have got internal targets that really drive the route to net zero, and they are then, to hit those targets, are driven to push us to come up with innovative ways to reduce the carbon footprints of our designs. So we are all the time trying to respond to them. Those are the institution and some of the larger developers. Because we work with a range of clients, we're finding that some of the smaller developers aren't so targeted, and they might have something they want to explore, but they need to see the cost benefit of it. And so the driver for the smaller client might be, a smaller developer, for instance, might be, well, we want to save carbon, but is it going to cost me X amount, and therefore make my project unviable? So there's a mixed bag.
Thank you. And Annalisa, I think you obviously had a great client in that cancer centre that wanted to embrace the work that you're doing. But how common is that type of client?
I think it will become increasingly common. We were incredibly lucky, as said, that this particular project was in Wales, and from the Act, the Wellbeing of Future Generations, that kind of sets the tone from the very beginning and provides a framework which is thinking longer into the future and longer term, and is part of that kind of cultural shift that we need to set kind of true purpose in our projects that are aligned with planetary boundaries and the emergency that we're in. And I think as that cultural shift is slowly happening, and as the demand drivers from the eventual end users are starting to shift, then hopefully we'll see that kind of ambition written into the project drivers from our clients much earlier on.
Okay, thank you. So we've got, and the next question is quite a specific one, I think aimed at Tim, specifically wanting to know a little bit more about the Carbonica tool, which you presented, and wondering, is that an internal tool for Morgan Sindall, or is that a tool that the supply chain uses as well?
Yeah, so that's so as a construction firm, we don't find it's in our, it's not natural to us to sort of license software, so it's quite a challenge for us. So a product like that, when it gets to the stage it's got, has a certain cost just to keep it running and develop it further. So in terms of sharing it for use, we're not able to do that. It's sort of beyond the realms of who we are, but we're looking at opportunities. How could we share it in the future? For example, we've received Innovate UK funding to work with the education sector to make it accessible as an education tool, and we're a month into that project now. So we are looking at it, but we're also trying to balance the fact we're a construction firm, not a software firm.
I think that's really interesting, and I was gonna. This is one of my own questions, really, but just looking at the challenges that there are for tier ones, and specifically, sort of managing supply chain emissions. What is Morgan Sindall's take on Scope 3 reporting? So those are the emissions that you're not directly responsible for. How do you approach Scope 3?
So when we back in 2018. I think we were one of the first construction firms in the world to have validated science-based targets. And for those who are not aware, science-based targets requires organisations like ours to set Scope 3 targets to reduce them. And we've recently signed up to the net zero pathway as well. So we have long-term targets by 2045 to reduce our Scope 3 by an almost unimaginable amount. So to achieve that, Carbonica came out of that. That was our response. As soon as we realised we had a target, we sat in a room together and said, we've got no idea of what the carbon footprint is of the buildings we deliver. We do of one or two because there was the budget to model it, but we don't of the sort of bread and butter project. So that's where Carbonica came from. So we use Carbonica to sort of jump through the supply chain layers to get data direct from manufacturers and piece it all together that way. It is a patchwork quilt, so Carbonica is part of it, and there are other data sources, but that really helps us.
And I mean, how common is that amongst tier ones? Do you think it is a real challenge for tier ones to get that oversight, because they've got enormous value chains, haven't they? It seems like a massive task.
Tier ones generally, I completely agree. Sort of various approaches have been attempted, collaborations between tier ones, and they're yet to come to fruition. I think the industry as a whole is grappling with how do we measure it? Do we go layer by layer through the supply chain? which would take ages, or do we find a different approach like sort of Carbonica and piecing it together from there?
Okay, thank you. Enough of my questions. I'll get on to Wendy's question, which is how can manufacturers really help you design for more sustainable outcomes? So I'm sensing that she's from the products side of the industry, and so she's saying, is it through offering innovative products, i.e., with low carbon content, or should we be focusing on educating, collaborating with designers and contractors earlier in the design process? So I guess she's sort of saying how much is it valuable to come up with innovative products, and how much of it is valuable to just keep the conversation and the flow of information going. I might come to you first, Annalisa, on that one.
Yeah, I think it's a good question, and I'd say it's a bit of both. I mean, we need to have the innovative products there that allow solutions. You know, as I described, we're trying to use a hemp block solution. However, there's so many constraints with trying to use a new innovative material because it needs to be tested and it needs to have the warranties and you have to have the fire certificates for a whole system. And at that point, we need to have much earlier conversations, definitely, so that we know that, okay, there will be new products coming to market to use, which is super exciting. But we also need to know that how do we use the products that are available in the most efficient and kind of long-term managing way? Because there is, whatever we use, there's a way that we design with them that allows kind of better longevity of that material in use, how your durability happens, as you know, colleagues have spoken about the demountability or deconstructibility of those things, and even how you start to layer things up for maintenance and being able to understand the cyclical process of maintenance, that something might need to come down without jeopardizing the rest of the building around it. So I think getting those things in very early and having real understanding of the materials and its properties, and using materials and products for their inherent properties and what they serve best is great. But then having innovation is going to be very exciting because we want to have more things available to us. We need to have new insulations. We need to have new claddings that can happen at different scales that are fully tested and ready to use.
Thank you. Does anyone else want to jump in on that question? I've got quite a few more in the list, so we can move on. I think that was a fairly thorough answer. So Lindsay has got a question around. Okay, so I think this might be more towards your presentation, Ashwin, where you would. I think you used the terms. What's the difference between reclaimed and scrap? And can you use scrap material? So maybe that's just a confusion amongst terms that are being used.
So scrap is essentially going to recycling. So that's going to be remelted and reformed as a new section. Whereas what we're trying to promote is harvesting. So we're cutting large chunks of steel, leaving them as whole as possible, so that we can reuse that in that same form. So those are the two very different things.
Chloe, I think you're on mute.
Sorry, rookie error. Thank you. I was just saying that I'm hoping that's clarified things for Lindsay, and I will move on to another question, which is from Roland around. Although the focus is on carbon emissions, what is the industry doing about other greenhouse gases? I think that probably speaks a bit towards your presentation, Annalisa, where you're looking much more holistically. But do you want to speak a little bit on that point?
Yeah, and I can be totally honest and say, you know, everything is aligned to carbon CO2 equivalents, and that's kind of like the currency that we're used to speaking about. I think that what I kind of touched on here now is the potential overlap between how we consider our agriculture and our land use, and what does carbon in the built environment have to play as a part of that. And actually, if we start to use materials that, as I described, could maybe be described as regenerative materials that kind of feed into the nitrogen cycle and the way that we lock carbon deep into the roots as carbon sinks in our land, and then also get something that can harvest out as a construction material. There's grasses and hemp that we're using, for example. How we look at agroforestry and what's happening, it's all about kind of land use and the balance of what we are taking, harvesting, extracting to use in the building, and what does that give as like a different value or local or regional kind of supply chain where you may otherwise have different industries. But in terms of kind of other gases that are greenhouse gas emitting from waste streams, I think if we do just in general look to make a more circular economy, reduce the waste, hopefully those things will all play into the overall reduction of greenhouse gas emitting products.
Thank you. And Tim, do you feel that the language that we use is important? Do we tend to just talk about carbon as a kind of shortcut, and then that means that we're not thinking in terms of the entire system and sort of whole life cycle and all of those things, or are we just talking semantics here?
Well, I think the semantics are really important because there's certainly a need across the industry for a foundational level of carbon literacy. For example, the point Annalisa made that when we say carbon, we almost always mean carbon dioxide equivalent, which includes the other greenhouse gases. And it might seem like such a technical detail, but that is the answer to that question. When we say carbon, we do mean, and refrigerants is a great example of that. Refrigerants leaking from a heat pump over 20 or 30 years is always converted into global warming potential compared to 1 kilogram of carbon dioxide. And in a carbon assessment, it would be that number, that equivalent number. And that's not a criticism, by the way, whoever asked the question about lack of literacy. I think it's just a general thing in the industry where that literacy would be helpful.
Okay, I think we've got time for maybe one more question, which is from an SME, which I think is very useful actually, because we've been talking about the supply chain. So as an SME, we struggle to get our supply chain to be able to provide EPDs, as they seem difficult, expensive and time consuming to obtain, with most of them still not being aware of them. How can we provide carbon data to tier 1 contractors while it's so difficult to obtain this data in the first place? Has the panel discovered any or are they aware of any alternative calculation methodologies which are cheaper and available? So I guess that's about how easy is it for these smaller operators to get the information that the design and the construction team are requesting of them. Tim, are you well qualified to answer that?
Well, just briefly, I completely empathise with that because they can be expensive. For example, if you are a building services manufacturer or SME, then CIBSE Guide TM65 sets out a route to publish a life cycle assessment without the validation side. And we do use in Carbonica unverified life cycle assessments sometimes where an EPD doesn't exist. I know, for example, I'm sure there are many options, but the BRE Leaner tool can be quite cost effective. I think one click, I think the cost will come down in time. But right now, I completely empathise. It can be expensive and off-putting, but it's not a must-have for us right now, and there are other ways.
Okay, so there is some flexibility in the system. Annalisa, you were nodding there. Do you have any other tips for this listener?
I'm not sure if I have tips per se, because that's not my field of work directly, but we do kind of say that we would always specify EPD is a prerequisite, but that's normally going to these, on larger scale projects, the larger scale suppliers who have the resource and should be producing them, and that's a means to try and make it more commonplace across the markets, just like push and put that pressure onto it. However, I think Tim said at the very beginning, looking at carbon isn't the only metric that we can look at, and there is some sort of intuition that you can take and as a designer or a specifier and understanding if there's a short kind of trackable supply chain, and you can understand where materials coming from locally, or if that's much more visible, I think for us we would then kind of have more leniency about the prerequisite to have an EPD to help kind of promote the use and pioneer the use of other products. But I think for the large players that we need to really be pushing to make sure they have the EPDs, and then we also need that kind of third party verification so it's standardized and we know that we're comparing apples with apples.
Absolutely. Okay. Well, look, I think that's a really positive message to end on. That we're not. There are ways for SMEs to still be included in this transition and not be excluded. So thank you very much for all of the questions. We didn't have time to get through all of them, but the presentations were so interesting, and I think we've learned so much. So I just want to say thank you to Tim, Ashwin and Annalisa, and a reminder that this session and the other sessions that are part of Net Zero Live will all be available on demand for you all to look at again, or for your colleagues to look at. So that's all we've got time for today, but thank you very much to my panel, and I hope that you will hear from them all soon about their really interesting projects. I feel like they are on the start of some very interesting work, so we would very much like some updates, I'm sure, in future from you all. Thank you so much, and goodbye.
Thank you, Chloe.
Thank you, Chloe.